Brendan Thompson is the operation manager for SWS Safety Warning Specialist of Niagara Falls, Ontario. SWS is a leading manufacturer of LED warning lights and was the strategic value engineering study partner of the Ministry of Transportation in Ontario for the snowplow visibility study. In this capacity at SWS, Brendan oversees many aspects of the business. Most relevant to this presentation is the new product development and collaboration and manufacturing operations. He's worked in various industries, including telecommunications, contract manufacturing, industrial automation. He holds a bachelor's degree from the Memorial University of Newfoundland, along with an accreditation as a certified engineering technologist in electricity and electronics. So welcome.
I guess first off, thanks for having me. Very honored and pleased to be here. Thanks for the introduction, Lisa. Ultimately, I'm here based on what Lisa said as an available study partner. So SWS is a designer and manufacturer of LED lighting systems. We're primarily serving the Canadian market. So we were involved in the visibility study and the development of the products along with the Ministry of Transportation Ontario. So ultimately, I guess one technicality that I have to clear up is I'm speaking about the study. I'm not speaking directly on behalf of the MTO, just a minor legality there. But the fella who led the study and ultimately did all the good work that you'll find in this presentation, his name is Mike Pearsall. And he left me with a pile of cards because as we're going through the presentation, if there's any particular questions that you might have, please, by all means, just raise your hands. If I don't feel comfortable answering it, I can refer you to Mike. I can give you one of his business cards, and then you can subsequently contact him. He's very, very disappointed that he couldn't make it. As I'm sure most of you can sympathize, getting international travel approval sometimes, takes an act of Congress. So. With 12 weeks notice, he unfortunately couldn't make it happen. So unfortunately, you're stuck with me. I'm going to try to make it not too boring because my first attempt crossing the border and discussing what I was doing down in the U.S. with the border guard, as I explained the context of the study, as he was trying to, I think, trip me up a little bit. He said, "Wow, that sounds incredibly boring." And then he subsequently let me pass. So if you want to put that in your back pocket for next time you're crossing the border, just bore the border guard to death and you can get away with just about anything. So we'll start off with a bit of an overview. I'm going to start with a couple video of examples, but I guess it's a bit of a hot button issue, lighting for during this particular conference. So talking about snowplow lighting in June seems appropriate, so happy to be able to share the study with you. So we'll talk about some of the particular issues that the Ministry of Transportation in Ontario was seeing, some of the things that they had to resolve, some of the factors affecting the study. What did they have to make themselves aware of before they undertook the study, the particular mechanics of how they set up the study, the pre-work, the literature review that they did, which was quite extensive, the value-added workshop, the value engineering value-added workshop that they undertook, and then ultimately the workshop results. What came out of it? What do we think is going to work? And then ultimately proving it. They had to make sure that all these great ideas that came out of the workshop were ultimately defendable, and then the subsequent implementation of this standard. So I'm just going to maybe cause a few more computer problems here and then pull up a quick video that Mike sent me, and I believe it is a DOT video, and the context of this particular video, to play it for you, is really just to characterize and exemplify some of the challenges in seeing snowplow equipment. So I'm going to pull this up. I believe this actually comes from Maryland. So the driver is obviously following one of the new tow plows, which anybody with snow in their state, I'm sure, is getting familiar if you're not intimately familiar with. And some of the subsequent challenges with operating the tow plows and the public awareness about them. So I won't run through the whole video, but even in this particular example, it's often difficult when following one of these to, one, immediately recognize that it's a snowplow. You can see the tow plow just starting to move really without warning. So, it could be surmised that if someone was going to take that exit, they were trying to speed past, and then the equipment starts to move, that could create a bit of a potential hazard. So it's much of this as they go through the video to show the tow plow operation, but as we get a little further ahead in the video, one of the particular items that was of concern with tow plows that they attempted to address throughout this study is on the rear-facing view towards the tow plow. Drivers who can't always be trusted to make a rational decision about what to do when surrounded by this piece of equipment. There were a couple incidents in Ontario where people pulling over to the side because it was at nighttime and they didn't realize that the tow plow was on, and as the tow plow came by without enough space to actually stop, obviously led to particular collision that the car's not going to win. Let's put it that way. So I hope this video helps to exemplify, clarify some of the issues that at least Ontario was facing. I'm sure you guys are facing it as well with respect to snowplow visibility. And I'm going to do a second video here, which is probably a little bit of comic relief for everybody because it's a commercial from Ontario that aired during the 70s about snowplow awareness. And I brought this just to indicate how long this has really been an issue. So I'll pull this one up. I'm sorry, and it's really unfortunate that this one doesn't want to play because it's pretty humorous, but I guess I'll summarize a little bit, but it's a commercial about snowplow awareness that came out in the 70s, published by the Ministry of Transportation in Ontario, and it basically says to the public, what do we need to do to get you to pay attention to a snowplow? And, checkerboard and light comes up. Do we have to put a tail gunner? And they actually animate a guy sitting on the back of the truck shooting at people. It's one of the more bizarre things. If I can get it to work, I absolutely have to show you. I know some of you may want to use that now, but I certainly wouldn't recommend it. So the next couple slides go along with what you saw in the video. What are some of the issues that actually affect visibility in the winter? Obviously, when it's a whiteout or night driving, the conditions lead to guesswork on behalf of the driver. And, really you want to make the decision as unambiguous as possible for them, that they can detect and recognize what they're driving behind. So one of the issues that we'll get to in a couple pictures in the next slide or two was the loss of brand identity. That just about every snowplow looked a little bit different. And oftentimes when the public is coming up on one, they're not immediately recognizing it as a snowplow. So it obviously, inappropriate driver reactions can lead to collisions, which obviously I think you guys probably know better than most. So the challenge was put forth that a new lighting standard was needed, and you can see it was in a very short time frame that the MTO was mandated to put something out. So they had a couple critical decisions to make on how to accomplish that. So the current service providers needed to be fully involved in the process. So because it was a short time frame, it had to work. They didn't have the option of failure. They really needed the buy-in of the area maintenance contractors to make this thing happen. So what they did, and you'll see as we go through the study, they tried to avoid a thou shalt approach. So in the next slide, what I can show you is these were the various snowplow vehicles and how they appeared to people on the public. So you can see and you can sort of rationalize that there was a little bit of confusion. They had lost their brand identity that, if I could show you the gunner video, you would have appreciated. But it was really since the 1980s that Ontario started outsourcing the maintenance of our major highways. So, having this discussion and getting ready for this presentation with Mike, it was interesting because he said to me, he says, what is the most easily recognized, ubiquitous vehicle on the road? And my first response was, well, a fire truck. It's big. It's usually got a ladder on it, a lot of sirens. And he says, you'd think that. He says, I would disagree with you. It's not police, because every jurisdiction has different colors. He says it's not paramedics, because sometimes fire rescue does that service. Sometimes, it's a big white Sprinter van, and the lighting can look quite a bit different from ambulance to ambulance. And he says, to me, it was school buses. Wherever you go in North America and you see a school bus, you never question the fact that it's a school bus. The chrome yellow, the lights, the painting, everything. He says, I really wanted to try to gain that same brand, that recognition of what you were behind with snowplows. So with snowplows, they had an additional challenge with the advent of the tow plows, being such wonderful devices that they are. Not only did they need to express to the public, recognize and react appropriately to what a snowplow is. Here's another big wrinkle. This thing has a massive tail, and it might slide in front of you. It might not. It may obscure your view. So in and amongst the study, they had to make a lot of extra considerations for how to handle tow plows, how to add additional lighting. So again, the public doesn't become confused, because that's ultimately the goal of this entire study, is to improve public safety. So when it came to, they've identified this problem, and they know they had a short window to solve it. So how the heck do they do it? And the committee approach, which is a very obviously common approach, he wanted to steer away from. They're often too cumbersome. They take too long. There's too many different opinions. And in a lot of cases, everybody has their normal day-to-day job. So to get everybody in the same room, all the different folks that would necessarily have an opinion over a year's time, felt that would be too cumbersome, and he wouldn't accomplish his goal of actually doing it within 6 months. So, maybe the owners, they develop the standards. And again, that's that thou shalt approach, which he really wanted to avoid. So the value engineering, the value added study, he had a great track record with in not necessarily lighting development, but in some other programs within the MTO. So he said, hands down, this is the way that I went. So it was very, very successful. It gets everybody who has skin in the game, so to speak, involved, and encourages a lot of collaboration. So we'll go through a lot of the steps that are involved in that value engineering study. So now that he had decided what type of approach he was going to take to solve this problem, he said, what are the factors that are going to affect this study? So, the never-ending controversy between what type of lighting technology to use. Obviously, there's a lot more LEDs on the road than there used to be, but we're still holding on to incandescent lights. Primary reason, at least from my experience in the lighting industry, is they generate heat. That's usually the biggest no-no in LEDs, but especially in snowplow operations, they melt the snow. So it's very difficult for people to let those go. So that has always been sort of a long-standing controversy. And then the blue controversy, which is, I guess somewhat particular to the province of Ontario, that at some point in 1948, they made a decision that snow removal can be blue, which obviously is not the case in most of the U.S. states. It's fairly prohibitive. And the MTO has been getting a lot of pressure from the local police forces because they love the red and they love the blue together for emergency and warning vehicles. That he had to decide, well, do we really stick with blue? Is that the answer? So that was something that was going to be tested throughout the entire study. So, and obviously, red was out of the question, because being in Canada, it has a very exclusive use for hockey arenas to tell us when a puck crosses the line. So nobody else, not even the fire guys can use it. Of course, I'm kidding. So, and based on this, how do we get people to agree and resolve this issue quickly, because again, it comes back to that time thing. They didn't have a lot of time to get this done. So as we get into the study setup, obviously we agreed that it's perfect for a value engineering study, even though it's outside our normal realm. They needed the full range of stakeholders, and even a little bit of background of how SWS became involved was, Mike said, I have a very short time frame, I have almost no money to do this, but I'm being held to this certain criteria that I have to get this done, so how best do I do this for free? Well, he went to the Municipal Equipment Operators Association trade show, and he went around to different vendors, us being one of them, some of our competitors being the others, and truck builders, area maintenance contractors, and said, look, I'm prepping for this study. Would you like to be very much involved? And obviously, SWS was successful in walking through the study, as was Viking Surveys. They were a very big part of this study, and they put forth a lot of resources to make it happen. And obviously, time will tell of how well it's working, but so far so good, I guess we can say. So obviously, he used the trade shows to bring people in and get them to buy in. And he didn't want too many people. So going back to having a committee, often, it's too many people, too many opinions, and, the bigger the wheel, the slower it turns. So it was just get the right people in small numbers who can have the most impact on this particular study, especially because, something like lighting technology has come a very long way in a very short period of time. It was unreasonable to assume that any one person, whether it was in the MTO or out in the trucking industry, really had their head around what's possible, what can we actually do if we're going to push the envelope with this particular study. So balance was a very important factor when it came to this study. So the response. So he had brought in a number of people. He held an initial workshop in July of 2013 was when this whole thing actually started. So that was 2 months after basically he received his marching orders to say, we need to get this done. So 4 out of the 5 major area maintenance contractors participated and provided very valuable input into generating ideas because, essentially they're the boots on the ground. These are the guys dealing with the issues every day. If there's a collision, they're the ones that are in it. And he tried to keep it simple right off the bat. He said, if you're interested, all I'm asking is one person for one day. That's all we're asking you to commit. If you're not interested, walk away, no hard feelings. And before the end of the first day, every person in that room who was involved in that initial study had committed to multiple days afterwards. Most people saw the value in what was happening in the way that this study was starting to come together. That thank God that we decided to do it. It's been a great venture for us so far, as it has for many of the other people who were involved. So it really, really worked well. So some of the pre-work, obviously, decide on the team. When bringing this study together, the human factors are important. So find a place that's generally convenient for everybody. In Ontario, it has to be Toronto because it's, the rest of Canada. It's the center of the world, but the location had to be easy to get to, avoid distractions. Didn't want to feel like you were in a cramped room, and even simple things like feed the people, feed them well. If they're comfortable in a creative environment, I guess a little bit of the Google approach that the best ideas will come forth. So, Mike ultimately led that study. And the one thing that he absolutely stressed, he said, now that we have this team together, it's important that everybody does a literature review so we don't make the same mistakes, maybe things that had been learned in the past. We don't want to have to relearn things. So we pulled together 800 pages of literature, and it wasn't just his responsibility to read those 800 pages. He went back to everybody in that study, whether you're a lighting guy or the tow plow operator, the bodybuilder, and said, if you guys want to be involved, and so far the commitment's good, but here's the true admission: read 800 pages of, I'm sure, what was very, very entertaining information. So if anything is going to be taken out of that was one particular point was, do your homework, get everything behind you and know what mistakes have been made in the past. So there were many things that came out of the literature review conclusions. So they were more or less subdivided. First two being detection of the system and then recognition of it by the drivers. So based on all the literature review that they had done, they'd come to the preliminary conclusion that LEDs were the recommended technology for a number of reasons. You know, they're low maintenance, especially compared to halogen and strobe, and they're also much more easily controlled. Dimming options, flash options. You know, essentially it comes down to just reprogramming a microcontroller at that point to make those changes. So anything that needed to be changed throughout the study could be done so without a lot of inconvenience. The one major downfall, like I noted before, that halogens have over LEDs is the fact that they generate the heat and the snow often doesn't stay on it. So LEDs are generally perceived as needing a lot more frequent cleaning. So that was something that had to be taken into consideration as they went through the study. Increasing intensity. I think there was a preliminary belief that it's always the brighter the better. But in particular situations, especially during nighttime, that can create a hazard, not prevent one. So trying to get rid of that idea that the brighter the better and the appropriate amount of light for the particular situation, which again went into the LED's corner as being the chosen technology. And of course, the more intensity that you have, it can result in quite a bit of glare. And again, that's creating the hazard and not preventing it. So optimum detection requires different levels of intensity versus day and night. LEDs, you can put them up, put them down with relative ease. And then blue, and this again is coming from the literature, was the most conspicuous color day and night and needed actually the least amount of intensity and thereby reducing glare. So obviously supported the long-standing decision to use blue in Ontario. But again, these are all just conclusions based on the literature. And throughout the presentation, we'll get to the point where they were actually tested to prove the concept. So staying on the topic of detection and how best to do that based on the literature was a short, intense flash. It had good detection like a typical xenon strobe would, but what it really did, it did not service the drivers in their ability to detect the closure rate. How fast were they impeding on this vehicle? Strobes are immensely bright, but it's often difficult for the human eye to detect its precise location because it's a quick flash and then it's gone. And then you're looking for it where, you know, if you have a steady on halogen rotator or a steady on LED, it's a lot easier to detect a particular application of the potential hazard. So the strobe really was the least desirable effort. And I know the province of Ontario has actually been issuing letters flat out saying we do not want strobes on the road. They're not legally prohibited by any means. They're just incredibly strongly discouraged. The second set of elevated stop-tail turn lights that currently is used on a lot of snow removal equipment, they were seen as being very beneficial based on the literature conclusions. And then any level of reflective tape, any of the conspicuity tape around the back of the dumpers were and the hoppers were obviously seen as being very, very beneficial. So once we get back past the point of detecting the hazard, it's recognizing actually what it was. So the stronger perception of hazard with the combinations of yellow, blue, and red than just with yellow or amber alone. What the literature suggested is that there's a lot of correlation when you have a red light on a vehicle to stop. Obviously, that's braking, and that's one thing that they wanted to avoid. So, not that they were ever going to get the use of the red away from the hockey arenas, but it was well noted that it wasn't of much benefit to go into that battle anyway, or drop the gloves, I guess. The connecting dots to convey the outline, and then again getting back to that brand recognition. That was one important part of the study. So the other part of recognition, again, besides identifying what the vehicle is and what it's doing, is that perception of the closing speed. So the example that Mike gave me that I thought was very relevant, when you look in your rear view mirror, what's easier to tell the closing speed, how fast this vehicle is coming up on you, a car or a motorcycle? And he says, it's a car 100 times out of 100, because you have two headlights and you have that level of perception that as they get closer to you, they get closer together. So the brain has the opportunity to process that information, but with a motorcycle and the fact that it only has one light, is very difficult to detect closing speed relative to a car. So having something that was wide, that assisted drivers in that, based on the literature, was also very important. And then longer duration lights. So rather than that flash, I don't want to keep beating up strobes, but having something on for a longer duration rather than something that grabs your attention then goes away, that keeps the person searching for it. So longer duration was better. So once you have detection, you have recognition, decision, and then response. So now the decision lies with the driver, whether to slow down or whether to pass. And obviously, as getting ready for this presentation, watching a lot of YouTube videos, it's amazing how many people decide to attempt to pass a snowplow, even if they're plowing an echelon, which is a bit of a death wish, I think. So obviously something that they want to educate the public to avoid. So, and then having that appropriate response. Evidence suggests that, speed was slower for the amber-blue combination than for yellow alone. And a lot of that came from the fact that in, work crews, maintenance in most jurisdictions, it's not multicolored, it's amber alone. So oftentimes when drivers are on the road and they see amber, they don't recognize it as an immediate hazard. They may slow down a little bit, or they're so acclimated to road construction because, in Canada we have 4 seasons. There's pre-winter, winter, post-winter, and road construction. So during the road construction season, there's amber all over the place. So there's a certain level of people getting acclimated to that. So the more they see it, the less they perceive the hazard, and the more inappropriately perhaps they react to it. The light bar with 6 sequential flashers was more effective than the 4-way flashers because that's something that people are used to. And then the rotating single beacon was also perceived as being effective as opposed to sort of a double flash strobe, because a slow rotating pattern suggested to the people that it was a slow moving vehicle. And that also leads to making a good decision on behalf of the driver that this is a slow moving vehicle and obviously very large based on the outline. So getting back to this detect, recognize, decide, and respond, these were the functions that they understood needed to happen almost in a very flowchart format. So what do we do to take all these things into consideration and develop a standard around it? So they developed a functional analysis system technique, and I don't know, this was actually my first time seeing this. I don't know how many people in this room have seen a similar level of diagram before, but it really, keeps the problem objective and maintains the scope in graphical format of what you're trying to achieve. So, and it's small for you, it's even small up here. So, what are you trying to do is ultimately we're trying to improve safety. How do you improve safety? You avoid collisions. How do you avoid collisions? You maintain a good separation between yourself and the potential vehicle that you're going to collide with. How do you do that? You improve driver response time. So maintaining that visibility, you improve the durability of the lights, you improve the maintainability of the lights, sort of making the case for LEDs again, and you improve the operation. The less downtime that you have fixing lights, the more time that your snowplows can be active and out on the road and doing what they're supposed to be doing. So improving the driver response time, you have to evoke a response, and you have to define that message of what they should be doing. So that comes to educating the public. And then you have to inform the public of the release of these particular devices. And once you relay that message, you have to attract attention, you have to keep the attention, and you have to establish that brand. So there's no ambiguity about what this monster machine is. You cue the vision, you locate the source, you improve the viability, you communicate that caution. So once you now getting into the recommendations that come out in the guideline, you have to convey the closure rate, you have to select the color, you have to select the markings, and then you have to indicate the dimension of it. So all of these goals, everything that MTO tried to accomplish, came out with a series of recommendations. And I guess the one thing that I'd want to be clear about is this is still based entirely on literature, just pulling in everything that everybody had and coming up with a number of creative ideas. So you can tell based on the number of creative ideas to improve the visibility and maintain the safe separation and educate the public. It was a big brainstorming session. So they had to filter those down and actually put a couple items into a real world proposal. So the initial proposal came out, and it was that the checkerboard was suggested over a chevron. They had started with Alberta. The province of Alberta actually uses chevrons quite heavily, but the feeling amongst the group was that the chevron, it encouraged forward movement and passing due to the arrow shape, where the checkerboard suggested more of a slow down or stop or take caution. So, and that the checkerboard had to be able to be removed, where most of these vehicles, actually talking to some of the folks out on the floor, they say, well, what's Ontario doing with these snowplow vehicles in the off season? In a lot of cases, because we use contractors, they're used for loading and hauling, and they're getting the most out of their capital, where some of the folks were indicating that some of these vehicles might sit all summer long. But the one thing that was important with this checkerboard, it had to be easily removable, and it had to be outlined by the conspicuity tape as well. But the one thing that wasn't a foregone conclusion based on the literature that needed to be tested was the yellow-black up there. It was primarily a suggestion. They needed to validate that through a little bit of study and scientific experiment. So I talked earlier about one of the disadvantages of LEDs is the fact that they don't generate heat, and they can require often cleaning. So the one thing that the province of Alberta did on all their snowplow equipment, because they certainly get their fair share of snow, they had airfoils on the back that would help to bring the oncoming air in and wipe clear a lot of the snow and items that might accumulate on the lights and inhibit them from being luminant. So that was one thing that they were going to try and validate to see that if it worked with this particular proposal. And then increasing the lighting at the end of the tow plow and the wing of the actual plow itself. So there are certain products out on the market, like the one in left-hand portion there. And then these are actual sketches that came out of the value engineering study in terms of what products are out there. Part of the reason why you're bringing in different industry experts into this study is, and what's actually written into the standard now, is the safety whip down in the corner. So it's not quite as bright as perhaps that light on the left, but that's reflective tape. It had a larger image, and it was indicated by the subjects during the test that it was much more visible to denote where the end of the tow plow was, or the blade itself. So I talked about closure rates earlier. The one thing that was felt very strongly coming out of the literature review was having an H pattern on the back of the vehicle, partly because the horizontal spread of that H pattern was beneficial for the driver to identify the closure rate of the vehicle, but also the top portion, the vertical portion of the H pattern, was very beneficial to convey the height of the vehicle as well. So you have an understanding of how big this vehicle is that's in front of you. And the rotating patterns were more recognizable than the flash patterns. And at that 1 hertz rotating rate, it was below what's considered to be seizure inducing. So thereby decreasing the potential of an additional hazard. So the upper blue lights would cycle in conjunction with the upper beacons. So basically, you have a mini bar on the top, actually on the front of the vehicle, and we'll get into a bit of an animation next that hopefully it cycles through and works properly. But the beacons would have, and the mini bar would have, and the warning sticks would have a steady on amber, so you can always detect where that vehicle is. There's no guesswork, it doesn't turn off. But then that blue light, the blue LEDs, which were considered to be the most conspicuous, would flash at that 1 hertz rate on the warning sticks, or they would cycle, rotate at the 1 hertz rate there. So I'm going to start the animation just to kind of give you an idea of what was started here. So I'm not sure it's perfectly timed on the PowerPoint, but to give you an idea that this was the initial proposal that they came up with. And I'm not sure putting that little Miller Group on there was subliminal advertising or not, but I'll ask Mike about that when I get back. So, you know, at this point, it's merely a hypothesis. So the new proposed design incorporated several added advantages: the LEDs, the effective communication of the plow location, the increased ability to estimate the size, the dimension, going back to that H pattern, and the standardization of all the light packages of all snowplow sanders. So it uniquely identifies that snowplow sander. There's not too many other vehicles on the road that would have that, you know, monstrosity of lighting on the back. So the other thing that they brought forth was the dimming option of LEDs was felt to be incredibly important in the study because of the difference between the light projected during day and night. So the one thing that they brought together about this study and that they were going to test is that the messaging boards, which I assume most jurisdictions in the US use as well, helps to provide the education to the drivers, what to do, use caution, let them know that there's one ahead, so they're, you know, aware of that impending detection of a snowplow. But we obviously have a bit of a wrinkle in Canada because the disadvantage was the fact that it needed to be bilingual. So anyone who speaks or has a basic understanding of the French language knows that saying anything in French takes a whole lot more words than in English. So we were starting to run out of characters. So they've had to come up with a couple creative abbreviations en français for that. So once the recommendation and the guidelines are validated and they're published, it certainly wasn't lost on anybody at the MTO that needed to educate the public, which is probably one of the bigger challenges that, as you know, DOT people you face on a daily basis, because you live and breathe this stuff, and unless someone gets into a collision, you know, they weren't aware that a lot of this information and safety guidelines even really existed. So they wanted to start a media campaign and get that brand recognition of the snowplow removal equipment out there, and greatly increase the driver awareness of how to behave around the snow removal equipment. So, you know, in our standard driver's handbooks in Ontario, all this stuff would be added. Social media, believe it or not, I don't know if this is anything to brag about, but the MTO Twitter feed was the most followed government Twitter feed for the period while they're going through this study. So it probably had a whopping 92 people following it, but still, first is first. And one of the other things that they did that I thought was really an inventive idea, the main highway that connects essentially Detroit to Montreal and runs the length of southern Ontario, all of the rest stops that house your Burger Kings and your Starbucks and everything along there, they're actually government owned, which I know is shocking for Canada, being the somewhat socialist country that we are, because we even have to buy our alcohol off the government. It's terrible. What they did is they took some of these study items, these sample trucks, and they did sort of a touch of snowplow events at all these rest areas along the road to get people familiar. So they would have members of the ministry standing outside before somebody went in to get their jolt of caffeine and said, "No, come on, you're gonna come touch a snowplow today." So, and it worked. And of course, you bring a 4-year-old boy past the snowplow and say, "You can climb up on it." There's not one parent that's getting away from having to do that, having a 4-year-old boy myself. So that was one thing that they at this point they were planning to do, and they ultimately did, and they thought that was a big success, and that was one of the ideas that Mike wanted me to pass on, because the whole goal here is to, try to benefit everybody in the room with the study that Ontario has done. So once that's all in place, all the paperwork's done, it was time to prove out the results, prove the concept that they had come up with. So as a quick summary, it was amber blue flashing alternately, or the amber would stay on, the blue would flash at 1 hertz. The red and white tape outlined the rear box. The light intensity was adjustable for day and night, and then airfoils present to keep it clear. So what they ultimately came up was, this was the render, and this is where a company like Viking Surveys was so incredibly helpful towards the study. They did the rendering, and they even actually did the body build on the first one, installed the lighting completely free of charge. And even the first lighting samples that we did, we actually built them half size. So the challenge for us was actually communicating and getting everything to sync in the manner that the MTO had determined was going to be best. So that was ultimately the feather in our cap on this whole thing. So they started with the model, and as I'm sure most people in this room can empathize with, this had to be a defendable solution. So if you're up on the stand and someone's questioning you about a collision that happened, and why didn't someone see the snowplow, to say, well, we studied all these papers and things that came out of the 60s, 70s, and 80s, and then this was our recommendation. Said, did you test it? So it was absolutely critical at this point to have a very fair, unbiased, scientific approach to testing this concept. So a lot of independent consultants were brought in. They actually brought in a number of PhDs who were experts in, they're considering the human factor, and then brought in the different age groups. So only less than 25, 25 to 55, and then 55 plus. So there was an equal distribution of test subjects to get a wide-ranging set of opinions. So the first thing that they did I'll go back. It was in November of 2013, was they were testing the actual conspicuity panel and what was the most recognizable color combination to the test subjects. So they did daytime and nighttime conditions, which that's actually a fairly bright day in Ontario in November. It's usually pretty overcast. They had a closed road, and they had the 12 test subjects. They tried, I think, up to 9 different color combinations that included black and white, amber blue, blue white, the yellow black. And the one thing he said, make sure you mention this to everybody as a tip. You might want to really plan out if you're going to do a similar level of test. He goes, I ended up changing panels 156 times in one day. He goes, I really would have scheduled it differently if I had thought about it a little bit more. So, but the results, the recommendation based from all the test subjects was that the yellow and the black checkerboard was the most conspicuous and the least ambiguous with respect to other vehicles that may be on the road. Next, it was time to test the light patterns and the configuration. So the first was a static position test after the yellow-black checkerboard was chosen. Each subject voted on the most conspicuous sequence, and the truck was driven back and forth to review and then modify the selections, and even the PhDs in some cases said, try to trick these people a little bit because they tend to get into a bit of a routine on some of the things that they choose. So that was closed road, and again, that was daytime and nighttime conditions there. So the next step was closing off some roads and doing some real world evaluations. So they compared the existing and the new lighting, and they did that in sort of daytime and nighttime conditions in February, which is a solid 6 hours of daylight. Winter conditions in Huntsville, Ontario, which is it's about 4 hours north of the city of Toronto, and it's in a bit of a snow belt, so it does get hit. That starts on Highway 11, that goes north from Toronto, and I don't think anybody's really sure where it ends up. It's so far up north. So this was actually a lights-only test. It didn't actually test the conspicuity panel and the recognition of that. They felt that that first test in November was solid enough evidence that it was overwhelmingly chosen to be the conspicuity panel. And what they actually did for each one of the test subjects, and they only used 6 in this particular test, to maintain a safe distance, they actually just taped a square on the windshield and made sure that they kept the rear end of the snowplow within that box so that every test subject was viewing it from the same distance. So there was a lot of very unhappy drivers trying to get up north when they were doing that test. So, like I mentioned, the testing in November confirmed the conspicuity panel should be fluorescent yellow, green, and black, the type 3-4 sheeting. There were some experiments done with higher reflective sheeting, and they actually found that to be a hazard. I think type 9 is often used, at least in Ontario, for school crossings and things like that, and they just felt there was too much of a reflective element there that it could actually create a hazard. And then the testing in December confirmed the optimal light output, that the solid amber and the blue flash, or the blue rotate. And what they did actually in that smaller picture, it's a little hard to tell. They brought out a typical construction vehicle, and they brought out a police vehicle. And with those test subjects, again, they lined them up, and it was a little more of a subjective opinion at that point. But basically, do you have any confusion between these vehicles? Can you are you confused that one might be a snowplow or a police vehicle or something along those lines? And it was very favorable that there was no confusion amongst the vehicles. So then the testing in February confirmed that the conspicuity was improved in both urban and rural collisions, and that the perception of the closing velocity was improved in order of 10%. And at first glance, I said, really, only 10%? And Mike said to me, he says, the amount of accidents that you will prevent by reducing that closing velocity, or that it's improved in an order of 10%, 90% of the accidents that occur may be in the last 10%. So it's not necessarily a one-to-one relationship. You could theoretically decrease a lot of collisions just by reducing it by that magnitude of 10%. But that's one of these things that only time and empirical evidence will actually suggest. So only a few more slides to go. So there was a couple of additional findings. They suspected this. The tests validated it, that automatic light dimmers were necessary. Originally, they had proposed the idea of putting a manual dimmer in the cab of the snowplow, but he said there was one really interesting aspect when we were doing the on-road conditions. We had one of the snowplow drivers from the area maintenance contractor. He said he was a really great guy. He was young, early 20s, drove the vehicle very well. He did everything we told him, but then we went and we asked him, and we said, what is your starting sequence in your plow? And he says, I go on, turn on my ignition, I hit this button, I hit this button, I hit this button. And he says, do you know what any of that means? He says, nope. I just turn it on and I go. So that led to the conclusion that the system that got installed had to be as automated and, pardon the expression, but dummy-proof as possible. So to avoid the condition where you have full intensity at nighttime, part of what was designed into the lighting system is that it's an auto dim only, as opposed to a manual switch. And then again, to drive home the point, strobe lights are just the worst. Sorry, I forgot to mention that the airfoils, they felt that they worked well, and there was some level of precedence with the province of Alberta having used them for quite some time, that their theory was ultimately proven. The one thing that they did review was the amber green, knowing that it is popular in other jurisdictions. It's actually a reserved color in Ontario by volunteer firefighters. So it really wasn't much of an option, but they actually felt that the visibility was less than the amber blue, and that's based on the responses of some of the test subjects as well. So the other item, and what's interesting from this picture, is he said, for most people, our belief was green means go. And even in this particular picture, the high-mounted beacons could be perceived as a green traffic light. So, even if the snowplow is coming to a stop, that green light's still going to be there, possibly thinking that it's going to head through some level of intersection. So overall project status, throughout that full calendar year from 2013 to 2014, the formal testing had been completed. They finalized a report, and actually since then the updated standards have been published. The Transportation Association of Canada has accepted this as a national guideline. So as of right now, the current status, this is a legislative requirement in the provinces of Ontario and Manitoba. We know through a lot of sales calls that the eastern provinces, the maritime provinces, are considering it, as well as are the western provinces, Saskatchewan, Alberta, and British Columbia. The City of Toronto, probably very unpopular to their maintenance contractors, have accepted it as a standard for the snowplows on their roads. And the one thing that's different from what the provinces have done is they've indicated that there's been no grandfathering. So they have to retrofit their entire fleet of snowplows. So also, in addition, the 407, which is the express toll route that goes around the north end of the City of Toronto, that if you want to travel, you stop, you drop off your firstborn, and then you get to drive on that road. They've done the same thing as the City of Toronto and said no grandfathering. Their entire fleet of equipment has been upgraded to this standard. So this is just a snapshot of a portion of the standard for the single axle plow. It does extend into the tow plows, the wing lights, and breaks down for almost every version of vehicle what's required. It goes beyond just the main lighting that was talked about in this particular discussion, but it gets into spinner lights and the stop, tail, turn, and the relative location of each one of those. And then I guess for anybody who is interested in purchasing the standard, the TAC-ATC website is up there. So that's where you would actually go to get it. $39 for members of the Transportation Association of Canada, $49 for non-members. So, and like I said, I've got a whole pile of cards for Mike. So he was very interested in anybody who wanted to contact him. He's very open to that. And then part of the public education campaign was the MTO published some news stories, which we've brought a number with us with my colleague Daryl at the back. He's got one. So if you're interested in reading up on how they disseminated some of this information to the public, you can see him on your way out, or you can pass some around if anybody's interested. So that does it for me. Hopefully I haven't embarrassed myself too much, and hopefully everybody got something valuable out of this. So I know that was Mike's intent as well.
I have a question. So the checkerboard, the yellow and black,
Yep.
is the black part reflective, or is it just flat black paint?
It's flat black. It's flat black. It's only the yellow portion that is reflective.
Okay.
What you'll see as part of the standard is there's actually 3 published versions of that checkerboard. So directly on the back of the snowplow is the full checkerboard. But when you have liquid anti-icing or the tow plow, there's 2 different versions that is half checkerboard. The bottom portion, which is I saw as very beneficial, it says caution, equipment may move. So conveying that message to the driver. It's also a bilingual one, which we were able to fit in the width given. And then there's a liquid anti-icing as well. So just to warn drivers that these things are occurring.
I just want to clarify, though, that the ministry contracts out their maintenance. So those trucks, while they're operating as MTO winter maintenance trucks have that. But in the summer, when they be used for non-DOT work, that's when you're having them take them off. So they're becoming like private industry vehicles in the summer.
It is, as an independent business owner, those area maintenance contractors can, unless they have, contractual restrictions, they can essentially use it for whatever they want. But I guess to even further drive home that point is unless they're undertaking snow removal operations or anti-icing, they should be removing it.
Other questions? Well, thank you very much.
No problem.